Yes, welcome back to the session. In this video, I am going to discuss about electric field due to infinitely long uniform straight wire. Okay, so look at this diagram here. We have an infinitely long uniform straight wire having positive charge. So this wire is completely filled with positive charge. Okay, as we know that the shape of the wire will be looks like a cylindrical shape. That is the reason I have taken a Gaussian surface also like a cylindrical shape. Okay, so we are going to calculate electric field, right, due to this infinitely long straight wire. So what I'm going to do here, I'm going to consider 3 points. One is the topmost point. At topmost point, the electric field is moving like this because the charge is positive. Electric field lines always radially outward direction. Okay, and the second region is nothing but middle region. So here also electric field always moving like a straight line. So this is also E and this is also E, and the last one is the bottommost point. So here also the electric field is moving like a straight line radially outward direction. So these are the three regions I'm going to consider, and I'm going to calculate electric field, right? So I'm mentioning here this is region 1 and this is region 2 and this is will be the region 3. Okay, so first of all, at highest region, that means the topmost region, surface area will be this one, right? That means if we increase the length of the wire, that means surface area also will increases along with the direction of the wire. The surface area I'm taking ds. Okay, so here surface area and electric field makes an angle theta, this value exactly equal to 90 degree, right? Because both are perpendicular to each other. Similarly, now coming to the second region, that means the central part. Electric field always moving radially outward direction, but at this location, if I take a small surface area, that is ds, so here the surface area as well as electric field both will be parallel to each other. So we can say that theta is equal to 0 degree, right? Now coming to the bottom region, at this location electric field is moving radially outward direction along horizontal direction, but if I increase the length of the wire, that surface area will goes downward direction, right? That means the area element, that means ds will be acting downward direction. So we can say that theta value here also is equal to 90 degree. Okay, so to calculate electric field, we will use Gauss law. Okay, so we know that according to Gauss law, closed integral E dot ds cos theta, which is equal to q by epsilon naught. Okay, so this is the Gauss law expression. Okay, so with the help of this equation only, we are going to calculate total electric field due to infinitely long charged wire. Okay, so we have three regions here: topmost region, central region, as well as bottommost region, right? So that is the reason this formula I'm going to split into three parts. Let's see. So I'm going to split this equation, closed integral E ds, the first region, no? First region means theta value how much? 90 degree, right? So I'm going to take cos 90 degree plus second region. Again, I'm going to use the same formula, E ds cos. So second region, right? So second region, what is the theta value here? 0 degree. Cos 0 plus closed integral third region E ds cos, what is the value, theta value? 90 degree, which is equal to q by epsilon naught. As we know that cos 90 value becomes 0, right? So the total term will be 0 here. Similarly, third region, here also 90 degree, so this part also becomes 0. So we are having only the second region. What is that? EDS cos 0. Cos 0 value is 1. So we will get the expression will be like this. Just a second, I will take the new page. Okay. Yes. So finally, we have only a second region, that is closed integral EDS cos 0, which is equal to q by epsilon naught. So cos 0 value already I told, which is equal to 1. So therefore we can write it as closed integral E dot ds, which is equal to q by epsilon naught. Okay, so here integration term will be there, no? So we are going to integrate the surface area element. Okay, so let's see, E I'm taking outside, E into closed integral ds, which is equal to q by epsilon naught. Okay, so here integral ds is nothing but s, right? So E into s, which is equal to q by epsilon naught, where s is called surface area. Am I right? So here, what is the shape of the wire? The shape of the wire, it looks like cylindrical shape, right? So that is the reason surface area of the cylinder formula is what? 2 pi RL, right? So therefore, E into surface area means we can write it as 2 pi RL, which is equal to q by epsilon naught. Let us assume this is equation number 1. Okay, as we know that here the wire, it looks like linearly charged wire. Am I right? So therefore we will use linear charge density formula. We know that linear charge density, it is denoted by lambda. So lambda is equal to charge by total length of the wire. Okay, so let us assume this is equation number 2. From this equation, I want a charge formula. So from this, charge is equal to lambda into L, right? So let us assume this is equation number 3. So this equation 3, I'm going to substitute in equation 1. Let's see. E into 2 pi RL, which is equal to, instead of charge, I'm going to take lambda L by epsilon naught. Okay, so this is the expression I got. Now what I'm going to do here, this 2 pi RL, I'm going to take right side, it goes to the denominator. Okay, let's see, I'm going to write again. So finally we got here E into 2 pi RL is equal to lambda L by epsilon naught, right? So I'm taking this total term right side, it goes to the denominator. So therefore E is equal to lambda L by 2 pi RL into epsilon naught. Okay, so here numerator length and denominator length cut. The rest of the expression will be E is equal to lambda by 2 pi epsilon naught into R. So this is the expression for electric field due to infinitely long charged wire, where lambda is called linear charge density. Okay, so this expression is most important for 5-mark question, especially for PU board, okay, as well as AP board also. Sometimes in CBSE also they will give in 5-mark sub question. Okay, so I hope you understand. Thank you so much.